Here's a couple of slides on band merging. So I'm going to start talking about it more generally, and then I will focus in on what we're doing for Ceph-C. So when I say band merging, what I mean is merging catalogs across bands. So bands means the range of wavelengths over which we've measured information. So like JH and K, Y is 1, 2, 3, 4, those are bands. And when you say band merging, you're merging the catalogs across those bands. Some of the catalogs you can get are already merged together. So for example, the 2-mass catalog has one line per source with the JH and K measurements listed, and the Y's catalog has one line per source with the Y's 4 bands all listed. But the catalogs are not merged together. So which source in the 2-mass catalog matches the source in the Y's catalog? And there's almost certainly going to be some sources in 2-mass that don't have counterparts in Y's, and in Y's that don't have counterparts in 2-mass, because you're looking at very different wavelengths. So ultimately, when you band merge, you're trying to create a master catalog where there is one line per unique object. And you're going to try to collect the measurements at all the wavelengths and all the other information you think you need, all collected on the same virtual baseball card, or the same, however you want to think about this, one line of a very big table, so that you have all the information tied together to that same object. So we're going to need this kind of information in order to make color magnitude and color plots and SEDs and all the other kinds of analysis we're going to do. So like I said, some existing catalogs already have done source matching, but some catalogs don't. And some catalogs have truly everything that they detected in the region. Some just list the things that they think were interesting. And not all catalogs are going to have exactly the same objects, because not all surveys integrate the same amount of time. Not all surveys are the same sensitivity. And the objects themselves are not the same brightness at all the wavelengths. So for example, given the shape of a star SED, a star is going to be brightest in the optical in JH and K, and much fainter if it doesn't have dust in the Y's bands, because of the intrinsic shape of the emission from the object. So the fundamental approach to band merging is you write code that says for each catalog that you have, for each object in one of those catalogs, you metaphorically sit on that one object and go look for any other matches within a certain radius in another catalog. And if you find one, then that's good. You say, okay, I found a match. Let's copy all that information over onto the virtual baseball card or the virtual row in the table. Did you not find one? So are you using the right radius? What's the positional uncertainties of the catalogs that you're matching? Is one arc second too small or too big of a search radius, for example, to match? What if you find more than one? Is the source really more than one source? Or is it a coordinate uncertainty issue? Can you match the patterns of the sources found in the two surveys to figure out which sources go with, are matched to the same sources in the other bands? Are you using the right search radius? Maybe 1 arc second is way too big and a half arc second would be better. Are the surveys the same resolution? If one is 6 to 12 arc seconds and the other is 1 arc second, it is quite possible that there is more than one source within that 6 to 12 arc second beam. If you can get your hand on the images, then you can resolve these issues. You can try to figure out which source or sources should be matched across the bands. Now, you can run into trouble when you do this in several different ways beyond what I've just described. What if different catalogs are using different coordinate systems? So 2-mass and Y's are based on J2000 coordinates. Maybe you have a paper from 1975, and in 1975 people were usually using the 1950 coordinates. Now, because right ascension and declination are extensions of the Earth's latitude and longitude system, and because our Earth precesses, the coordinate system changes slowly with time. So the coordinates that a certain source had in 1950 units is not the same as the coordinates it has in J2000 units. So you have to convert them before you can do the match. And there's uncertainties in that conversion. Radio observations are often tied to pulsars across the sky. So they have very, very high relative positions, but it's fundamentally a different unit, a different coordinate system than it is for 2-mass. They should be very similar, but you could run into problems if you're doing very, very small tolerance matching across catalogs. Or if you have something from 1956, maybe the coordinates were determined from photographic plates, which means that they're not necessarily high accuracy coordinates, in which case you probably have to do the matching by hand looking at the images. Fortunately, if you have all recent catalogs, like we do in Ceph-C, this is not really a huge problem. It matters more the richer the literature is on any given source. It's also true that different catalogs have different spatial resolution and different coordinate uncertainties. So for example, the Y's spatial resolution is worse than Spitzer, but both the Y's coordinates and the Spitzer coordinates are tied to 2 mass coordinates, and so they're all pretty good. In general, for my matching, my band merging, I look for things within 1 arcsecond radius, and then I adjust that on a per catalog basis depending on what I find. I have to calculate the offsets in right ascension and declination using spherical trigonometry between these any two sources, because the lines of constant longitude or the lines of right ascension come together at the poles, and so you have to worry about where you are in the sky in order to figure out what is the difference between two sources. Is it really 1 arcsecond? You have to do the spherical trigonometry properly. You need to make sure that the match is reasonable. Usually what I do is I have the computer do the match first, and then I go back and check for the important sources by hand. So in practice, you need to obtain the catalog first. At least for me, what I do, I obtain a catalog first from 2MASS because it has because it's in the near infrared, it has a decent number of sources that are seen both at optical and farther infrared, and so it works really well to provide an anchor for both shorter and longer wavelengths. And 2MASS, because it's over the whole sky, has really good coordinates. So I read it in, including not just the JH and K magnitudes, but the uncertainties in those, the data quality flags. I get rid of the photometry for those that have bad data quality flags, but I keep the coordinates. Then I read in the WISE catalog, which includes the magnitudes and errors and data quality flags for all 4 WISE bands, match them together, and then for each one of the matches that I find, I copy over the cross IDs and the magnitudes. But if there's no match, I create a new source in my catalog. Then I do that again for any other catalog. I'm going to match to this combined 2MASS plus WISE master catalog, and for each match I find, I copy over the relevant information. Some of the sources that I want to add into this may not be in the existing catalog, and depending on the goals, I may add them as new sources, or I may just let them go. So for the Ceph-C project in particular, what I'm doing is I'm reading in the 2MASS coordinates first to establish that baseline grid. Then I have Spitzer from the cryogenic era. Those coordinates are also really good. Merge those together. Then I also have the catalog that identifies candidate YSOs from the Gutermuth 09 paper. There's a literature YSOs, so those get merged in. Then I have glimpse data, which is Spitzer data from the post-cryo era, and it should result in fluxes that are similar to the Spitzer I1, I2 bands from the cryogenic era, but these sources vary, so they may be different, so I merge those in. Then I have the Sloan catalog. Now, because what I'm doing is focused on the infrared, I am going to have the luxury of dropping Sloan sources that don't already have matches in the catalog. And that's good because there are a lot of sources in the optical. And so if I can have a good scientific reason for dropping the optical sources that don't have matches already in the catalog, then I save myself disk space and time. Then I do that again for IFAST, the same thing, dropping the sources that don't have matches. Then we have 2 H-alpha bright sources from the literature, only 2. So those I matched by hand. Then I have WISE merging in. Now, it turns out because we have such a wealth of infrared data, I have the luxury, for now at least, of dropping the sources that don't already have matches in the catalog, because everything that I have in WISE should already be detected in the other bands. We'll see if that's justified when we get into it. I have the SCUBA data, the 16 sources from DiFrancesco et al. And I have the YSOVAR data, so those positions are really good. I can match those in. And I have the Chandra data in X-rays, and ultimately we'll have the Herschel data too that we can match up. So here's the visible representation of this. So this is right ascension and declination. This is the 2MASS catalog. As you can see, I asked for a circle in the sky. That green square is the region in which we are interested. So everything that's in the 2MASS catalog has a plus. The next slide, now I have the baseline 2MASS catalog is now black, and pluses in the background. Now the additional red diamonds are the data in the 2MASS and the cryo Spitzer catalogs together. So you can see I've got pretty good coverage over the region in the green square, but the corners are missing. It's not as dense sources. That's because the data that went into this, the IRAC data is that rectangle, and then the Spitzer data is the larger rectangle. So there's fewer sources in the corners. So now I have in the Gutermuth 09 tagged YSOs. So those are just the red dots. So you can see everything else is the existing master catalog now is the black, and the new things are the red dots. Now the glimpse data, I forgot what size I had asked for 2mass. So I asked for a little bit too large of a catalog. So you can see it covers the whole sky, but it definitely covers the region where we had information before. Now we're going to end up zooming out a little bit. The Sloan data covers almost all of our green square. It misses the corner. That's okay. But you can see the black underneath there is really, really dense with sources. So that's why I'm glad we have the luxury of not including Sloan sources that don't have infrared counterparts. Also here you can see some artifacts, right? You can see some streaks. There's not really sources in the sky lined up like that. So we're going to have to track some of those down. Here's what happens when you add in the IFAST data on top of that. So again, pretty well covered inside the green square. And then the 4 H alpha bright sources in our region, and then just 2 inside of our green square are there. Now the WISE data, I got smart again and asked for just a smaller cone on the sky. Again, we have pretty good matches in there. And then those are the scuba sources right in the middle. So that's all we have for our catalog now.